first. Okay. So this is my TCP. I'm doing exactly the same thing. Okay. It's listening on port 10,001. Okay. And then I'm going to start a TCP client. Okay. This will be my TCP client. Okay, type something. And that TCP client, when it starts, it actually already connected to the server. So the server will show up with the thing is connected. Then I'm doing here, and then the server receive them, and then he coming back, put it back, that uppercase go back to the receivers. Okay, so very much, that's all there is. Okay, then I do the end, I close it up. Okay, but we'll get to the why that is. Okay, in a minute. Okay, it's because it's by design that we want the guy to be just go ahead and close it out. Okay, so let's look at the code. The code, simple code here. So again, we import socket. Oh, I need to import sys also. Okay, because there are certain things that I should be able to do with a better print format, that kind of stuff. That's part of the sys library. So I import a socket using the socket library. Now on this one, actually, this is a better design because I copy this part from some of the internet examples. Then you do set constant, basically the pound define host and the port. Okay, and then create a socket again here, but instead of the datagram, when you create TCP socket, it's called sock stream, because TCP is a streaming protocol. It's not a datagram protocol. Datagram means one and that's it, So we can have multiple clients talking to the same socket. Okay, multiple clients talking to the same server. Okay. So the TCP wise, that we create a socket as a TCP socket, streaming socket. Then server side, you bind what? Bind the socket to my local port 10,001, local host port 10,001. Okay, so the bind is the same on the TCP or UDP because you need to have a socket assigned to a port. But basically it's tied to a port. That's why it's called bind. Then this is the important one, is listen. Okay, listen means that he is here and he's going to start to waiting for things to coming in. In the UDP case, okay, we don't have specifically calling about listen. Okay, so we just go ahead and do a receive. Okay, try to receive. But in terms of the TCP, your TCP has these three-way connections. So you got to do the open, the sync act, that kind of stuff. And that's what this listen is for somebody to connect it to him. So the socket, okay, the TCP server, he listen on what? On that whatever the port he is binding it to. So in these cases, this TCP echo server is listening on port 10,001, waiting for somebody to connect, Okay, so he's listening out, and once he get connected, somebody do the connected, then he will do accept. Accept is starting the process of that particular incoming connection. And once he starts to get somebody connected to him, he will do receive. See, this is different. So this is receive. It's not like the same as the UDPs. Okay, the UDP's connection is that receive from. There's a UDP socket form. Okay, the TCP socket form is really receive. So it's that the creation, bind, listen on the server side, and then with server side to accept. Accept pretty much is just like a receive, except that they're using different name for it. Okay, so once you accept, then you receive that guy. This is connection, acknowledgement, receive it. Then the same thing as you print out the data, and if there's no data is break, then you send it back. It's the data is send all. That's where the receive and send. Okay, so he is going to continue on doing that. What? Doing that, the same connection. Remember, this is the same connection. Okay, because he accepted one connection already. So this is going to be working on what? Working on the connection. It's the same one. The same one is get connected. And he is going to loop there, waiting for that guy to finish. And then he's done, he's close the connections. Okay, so the client part. Any questions about the TCP server? Okay, the client part. Okay, the client part is similar thing here. Then create a socket, and it's a TCP socket. Then connect. He is doing the three-way handshaking with the port, with the server. Okay, I didn't do any type of error checking, okay? So this is really just a simple demonstration thing, okay? So connect to the server. Once the connection is done, then he will do send the messages. Send the messages. Send what messages? With the message we typed in. Okay, and we send the messages. Again, we send a message in Unicode format. And then he will do a receive, try to see receive coming back from that. So this is only 1024 because it's not 4096. It's just whatever the numbers we do is just the size of the buffer. Okay, now in here, then you just continue on to type, but to input. So in that scenario here, okay, it's really, we just keep typing. Okay, so virtually this is the same connections. And other people won't be able to connect to this guy. Why? Because it's the only single connections. It's a single connection. So if we close this guy will be done. Okay, because you close it, then he will not be able to continue on. So he's going to be finished up. Okay, any questions about this client and server?
What does the B at the beginning of the messages mean?
Say it again.
What does the letter B before the messages mean?
Oh, it's binary.
Okay.
Yeah. Okay. That's the Python's format. I think Python people should be able to comment on that. I learned that thing recently. Any question? You want to try TCP? Okay, one more thing I want to bring your attention, okay? So what we are demonstrating you here are really such a simple program. In real life, this TCP won't work, okay? UDP, if you're going to use the UDP server code here, it will be okay. Because why? Because UDP server here can actually handle multiple UDP client. But the TCP servers, I just show you, it won't be able to handle multiple clients. Why? Because once you accept, you are bounded by that particular connection. So this is not the TCP servers doing. If you're going to be a server, you want to be like your Amazon server, you cannot say that, oh, somebody connected to me, then I'm just tied to him. Okay. So for TCP server to actually work, is really after you accept it, usually you spin off another thread. Okay? You have another thread to take care of a user. So in essence, what it does is that, let me get any of my, okay. In essence, is once you accept it, okay, you will spin off another thread. This will take care of a particular socket. Basically, it's socket 1. It's a socket, the particular user. And then he will continue to keep waiting for him. So the waiting, the accept, okay? This, you got listening. After you listening, you got listening, and you were sitting here and waiting for accept. Once the accept coming back, you spin off a thread, so it's separate thread. So he is continue to listening on this guy, continue listening on this guy. Okay. So this is one, you can say one task, or yeah, let me use the task. One task is doing that. This is another task will do that. Okay. Then the second person comes along, he is going to be the open, the sync act and all that stuff. Once it's done, then he is going to spin off another one. Okay, then the third person comes in, that's another one. Fourth person comes in. So you could have client 1, client 2, client 3, client 4, but this is all under the server's software. So in order for you to write a server, the real applications, okay, the server side, almost for sure, you need to have multitasking. So it's either you do a thread programming or you do a multi-process programming. Okay, I hope you understand what I'm talking about. This is really the operating systems stuff. Okay, and for UDP, that's not the issue. Why? The UDP is supposed to be that I'm here, I will receive here. After I receive it, I just go ahead and process them, and I will go back to receive. And I'll process them, I go back to receive. I process them, I go back to receive. Okay? Yes, on the UDP, if your process take a long time, then you may want to also do that multiple thread thing, just like TCP. Okay? But because of the UDP's nature of there's no state machine, it's really that just the things coming in and going out. Okay, then you can allow you to only have a single thread processing on UDP. But TCP, no, it's not the case, because once you connect, once you do the connection, then you are very much tied to that particular guy there, okay, particular connections until it get closed out. Okay, so that's part of the reason why the socket API, when you talk about network APIs, network programming, you will spend a lot of time is actually doing the operating system programming. Okay, and that's an important part. That's an important part too. Okay, but just to get a idea of what it is. So this is really what we are trying to do today, is just give you an idea of, okay, so what's involved in socket programming. It's easy to do a simple one like we are doing with the echoing, okay? But any type of real thing, unless all you are doing is really doing the client, okay? If all you are doing is doing the client, your client on the UDP and the client on the TCP would be very, very similar, very similar. Okay, you can take a look at the code. They are very, very similar. Okay, but the server part is almost, I would say, it can be the same, but it's going to be much more complicated. All right. Any questions about socket programming? Is socket programming relatively easy? Well, not programming. Well, programming, just like any other programming as I encountered, okay? It's easy to get in, but it's not easy to get good. That's really my opinion about being a programmer. Yeah. It's just take time to continue to polish, and the more mistake you make, the better you are as a programmer. Really, yeah. Okay. Any other questions you